This video covers the Unit 6 review, and we'll start with our first set. Numbers 1 through 8, we're just simplifying with exponents and radicals. So if we have 9 to the 1/2, this means if we take 1/2 and think of it as exponent form, it's the square root of 9. And the square root of 9 is just 3. So our answer for that one, 3. Number 2, if we change that to exponential form, it means we're looking at the cube root of 125 squared. Now the cube root of 125 is 5, which leaves us with 5 squared, which is 25. Number 3, now we're looking at simplifying within that radical. Now since it's a square root, we're looking at pairs of factors to pull out. So for example, 8 is 2 times 4, or 2 times 2. Since I have a square root, I can take a set of 2's out, but since I have an odd number of 2's, one will stay in. I have x squared, so that pair comes out, and it's just x. And then y to the 8th is actually 4 sets, so that'll be 2x y to the 4th. And inside of the radical will be a radical 2. For number 4, if we look at 18, 18 is 2 times 9, which is 3 times 3. So I can take a set of 3's out. So I'll make sure I put the 2xy squared times 3's come out. 2 stays in. I have x to the 6th. That'll be 3 sets, so x cubed. Y to the 9th. I could take 4 sets out, because that's y to the 8th, which leaves me 1 y left on the inside. I can now piece together the values I have on the outside. I have 6, x to the 4th, y to the 6th, times the square root of 2y. For number 25, I'm going to simplify before I deal with the radical, because 8 over 25, well, those are going to stay the same. I can't reduce those two values, but what I can simplify are the x's, because I have x on the top, x cubed on the bottom. I have 2 more x's on the bottom, so that'll simplify. Now when I apply the square roots separately, I have the square root of 8 over the square root of 25x squared. Square root of 8, I can take a set of 2's out, so that'll be 2 root 2. And then square root of 25 is 5, square root of x squared is x, so my answer is 2 root 2 over 5x. Number 6, I'm going to reduce this one first. 2 over 32 actually reduces to be 1 over 16. I have x, 1x on the bottom, so that'll stay. I have y squared on top and y on the bottom, so I'm going to have one more y when I simplify left there. So it's going to be the square root of y over the square root of 16x. Well, square root of 16 is 4, so now I have the square root of y over 4 root x, but I have to rationalize the denominator, so I multiply the top and the bottom by the square root of x. So I get the square root of xy over 4x. Number 7, I'm looking at cube root. So whereas square root I needed 2 sets, for cube root I'm going to need sets of 3. So it's the cube root of x over the cube root of 2. And now I'm going to rationalize the denominator by multiplying the top and the bottom by the number of 2's I need to make a set. So I need 2 more. Now this is really the cube root of 4, but we just write them out as separate 2's so we can look at the factors. So inside the radical on top I'll have 4x, and on the bottom I'll have a 2. That's outside the radical, so it's the cube root of 4x over 2. Number 8, in order to simplify or combine these terms and subtract, I need to first have them have like radicals. So if I look at 32, 32 is 4 times 8. So that means I'm going to be able to take not a 4 times 8, 16 times 2. Let's try it again. 32 is 16 times 2. So I can take a 4 out. Since it's x cubed, I can take an x out. that leaves me with 8x on the inside, which looks good because the other one has an 8x on the inside. In fact, it also has an x on the outside, so it's really that I'm subtracting is they both have this common term, x root 8x, so it's 4 of them minus 1 of them leaves me with 3x times the square root of 8x. Okay, now we go to our next screen. Now we're solving with our radicals. I have the square root of 2x minus 1 equals 5. So to clear the radical, I'm going to square both sides. Leaves me with 2x minus 1 equals 25. I add 1 to each side and I get 2x equals 26. So x is 13. It's always good to check these answers. If I do 2 times 13, that is 26. Minus 1 is 25. Square root of 25 is 5. So that one fits. For number 10, I'm going to first divide both sides by 2. So I have x to the negative 1/2 equals 3. And I'm going to multiply, or not multiply, but put both sides have an exponent of the reciprocal of negative 1/2. The reciprocal of negative 1/2 is negative 2. So it's going to be x to the negative 1/2 to the negative 2 equals 3 to the negative 2. And the goal here is that gets rid of the exponent on the x, and then I have 3 to the negative 2, which is actually 1 over 9. We look at number 11 now. We want to get that x, or that exponent by itself. The first thing I'm going to need to do is add 1 to both sides. That gives me an 8 on the right side. I can divide both sides by 4. I have x to the 1/3 equals 2. So I'm going to give both sides an exponent of the reciprocal of 1/3, so to the 3rd. That gives me x equals 2 to the 3rd, which is 8. For number 12, I need to look at the domain and state the domain. Since this is just a set of points, I'm really looking at the x values that I have. So the set of x values that I have for the domain is negative 2, 5, 6, and 17. The range would be all the possible y values. Now for 13, I need to find the domain that works. And this one is actually a function, so it's looking at where x will work. And there's a certain place it will not in this case. And anytime we have a fraction where we have our x value in the denominator, we have to take into account an undefined term. Because if we had a denominator of 0, that would give us an undefined value. And let's say x was negative 2. If x was negative 2, we would have 5 over 0, which is undefined. So our domain is going to be all reals except when x equals 2. Not x equals 2, x equals negative 2. Now for 14, we're going to use that same idea. We're going to have to actually factor the bottom first. And we can factor it down so that our quadratic here, x squared plus 4x plus 3, factors to x plus 1, x plus 3. And what this tells us is if x was a solution here, it's actually negative 1, negative 3. If it was either of those values, we would get a 0 in the denominator, which means we would have an undefined term. So for this one, 14, our domain is going to be all reals except when x equals negative 1 and negative 3. Now we go on to some function operation problems here. First one, I have f of x and g of x given at the top, so I'm going to substitute in negative 9 into f of x. It gives me negative 3 times negative 9 plus 5, or 27 plus 5 is 32. I do f of x plus g of x gives me negative 3x plus 5 plus 4x squared minus 7. Combine like terms, I get 4x squared I have negative 3x, and then minus 2, because negative 7 plus 5. G of negative 3, we plug in negative 3 to 4x squared minus 7. Negative 3 squared is 9. 4 times 9 is 36. Minus 7 is 31. For our composition problem, we need to find f of negative 2 and then plug that in to g. So f of negative 2, we'll start there, is negative 3 times negative 2 plus 5, or 6 plus 5, which is 11. Now, to get g of f of a negative 2, we're going to substitute in and make it g of what f of negative 2 was, 11. So that is 4 times 11 squared minus 7. Now 11 squared is 121. 4 times that is 484. And that's, of course, minus 7, so we get 477. Last one, we have g of f of x, and this is where we're going to take f of x and substitute it into g of x. We don't have a value here, but if we take f of x, which is that negative 3x plus 5, substitute into g of x, we're going to have to simplify that. We could square negative 3x plus 5. You could use FOIL, you could use box method, any of the various methods that we have. You get 9 9x squared minus 30x plus 25. And then tack on that minus 7 to the end. I now distribute out the 4. I get 36x squared minus 120x plus 100 minus 7. So we get 36x squared minus 120 plus 93. For 20 through 22, we need to determine if it's a function or not. And what's going to allow us to have a function is as long as we have any time we plug an x value in, we get a unique solution. So if I have multiple results for x values, that'll be a problem. So for example, on the first one, 1, 3, and 4 are the x values I would plug in, and if I did, I would get a unique result, so yes, that is a function. Whereas I look at 21, I have duplicates for the 1, and what this tells us, if I plugged in 1, I could either get 2 or I could get 3, and that does not give us a function because for each value we plug in, we should get a unique solution. So it will not change. So this one is a no. And then we looked at 22, we have 3, 2, 5. They're all unique, there's no duplicates, so that one is a function as well. So anytime those x has duplicates, multiple points for x, the same x value, that's when it will not be a function. Now before we look at 23 through 30, we're going to look at a rule we have, which says if n is odd, in the nth root of x to the n, then it equals x. It equals that value that it is. But if n is even, in the nth root of x to the n, then we get the absolute value of x. And that rule is really going to help us go through and solve these. So we start with the first one. We have the square root of w squared, which is, n is 2, so that one comes out to be the absolute value of w. That's true, that fits the rule. 24 is actually, if we rewrite it, the square root of y squared squared. So if we looked at that one, it should actually come out by the rule to be the absolute value of y squared. So that's false. We have the cube root of k to the third. By our rule up there, it should equal k, not the absolute value. So we get k. Or it should be false. 26, it's an even root, so it should come out to be absolute value. What we had was false. 27, we have odd roots. That's 5. It's odd. That comes out to equal its value. So that one is true. Now 28, we have the cube root of x is always a real number. So what that is saying is, can we plug in any value for the cube root of x and get a real number? Will it always work? And this one does work. This one is true. And something to consider is whenever we take square roots, we run into issues when it's negative because we get an imaginary number. But cube roots work a little bit differently for us because we could take a cube root of a negative number and it still works out. For example, the cube root of negative 8. That is negative 2 to the third. So whenever you have cube roots, we should take into account that real numbers do work. Now we look at 29. 29, we have the sixth root. Now the sixth root is an even root, and an even root is going to apply the same way that the square root would. In a square root, we couldn't have a negative and get a real number. It would turn out to be imaginary, so that one is false. Now 30, square roots will work, again, if they're just positive, but it's not just strictly negative and positive, because we have that x plus 1. Because let's say x is negative 1. If x was negative 1, we'd get the square root of 0. But if x was a little bit more than that, or a little bit less, we should say, a little bit less than negative 1, maybe negative 2 or negative 0.5, we get a negative. So this one is not always a real number. This one is false, and that's going to be false when x is less than negative 1. Now on to 31, we need to find the inverse. Whenever we find the inverse of a function, we can always write it as terms of y and x. And to find the inverse, we switch the x and y, and we resolve it so y is by itself. So in this case, I get x equals 7y minus 2. I would add 2 to both sides. I would then divide both sides by 7, and I would get x plus 2 over 7 equals y. So the inverse would be x plus 2 over 7. Same idea on number 32. We're going to say y equals x over 3 plus 6. We switch and write x equals y over 3 plus 6. First thing we'll do is subtract 6 from both sides. Then we multiply both sides by 3. 3x minus 18. And so our inverse of g of x, is 3x minus 18. Now 33, it's a little tough to see. What it actually says is the 8th root of x to the 8th, and this goes back to what we did on the last screen. Hope if I wrote it nicely here. What we did on the last screen where we said if it's an even root, it should come out to be the absolute value of x. It'll be the positive version of that number. So absolute value of x is our solution. 34, it says 8x to the negative 1/2 equals 16. We're going to first get the exponent isolated. So we're going to divide both sides by 8. So x to the negative 1/2 equals 2. We now put both sides to have an exponent of the reciprocal of negative 1/2. So the reciprocal of negative 1/2 is negative 2. So that's 2 to the negative 2. If we move over here, we get x, and 2 to the negative 2. Well, with the negative, it goes underneath the fraction, so it's 1 over 2 squared, so that'll be 1 over 4. Last one we have is some function operation. We have to add the 2. So that's going to be x squared plus 4x plus 7 plus 2 times x plus 3 squared. I'm going to square x plus 3 first, and that gives me x squared plus 6x plus 9. I'm then going to do distributive property with the 2 and get 2x squared plus 6x plus 9. I can bring down the x squared plus 4x plus 7, and now it's going to be combining like terms. I have an x squared and a 2x squared. That gives me 3x squared. I have a 4x and a 6x. That gives me 10x. Oops, I forgot to distribute the 2. Almost missed it. Almost finished the whole thing without an error. So let's clean that up. Hopefully you noticed that better than I did. So we should have distributed the 2. So what do we have here? Well, this was 6 and this was 9. So that when we distribute the 2, it was 12 and 18. Now, back to our x squareds. Those are still good. I have 4x plus 12x is 16x. And then 7 plus 18 is 25. There we go.